Hello, Anne, and hello to everyone. And I'm very delighted to welcome all of you to the session with Anne Currie. Anne has worked in the tech industry for 25 years as an engineer, manager, startup founder, writer, and speaker. And these days, she's co-writing the O'Reilly book, Building Green Software. And yeah, and very nice, interesting fact, she also devised and delivered the first tech ethics course for a major UK university, I read here. Yeah, and it's wonderful to have you here at the SAG. And now I hand over to you. Thank you.
Well, hello, thank you very much. And hello, everybody. I'm extremely pleased to meet you. Now, I'm going to disappear off the screen for a bit because I need to go over to my slides and step through them. But welcome to the talk. Hope you enjoy it, and I hope you have tons of questions to ask later. What am I talking about today, and who am I? As it's just been said, I've been in the tech industry actually nearly 30 years these days, starting in the kind of world of highly efficient C programming languages and C servers and networking code, that kind of thing. And these days, I am the co-author of Building Green Software, the new O'Reilly book on what we need to do in the tech industry to handle the climate transition. I'm also on the leadership team of the Linux Foundation's Green Software Foundation, and I'm the CEO of Strategically Green, which is a new company which is there to help to provide some training around this stuff, because we really need it. It's amazing how much we've got to do and how little we know what we need to do, but it's all totally doable. Don't panic, it's totally doable. So I think the first thing I need to say is I'm not a doomer, because there's so much gloom and doom and gloom followed by inevitable doom around the energy transition and climate change. But I'm not a doomer. I think that humanity is pulling itself together. It's amazing. I've been doing this for quite a few years now, and it's amazing how much better we are at doing this stuff now than we used to be. And not just better at it, we've got more tools, we've got more awareness. The world is really waking up to this. I believe, I'm 99.29 certain that humanity will survive climate change, but I'm 100% certain that not all enterprises will, and not all software will. And that's what I'm going to be talking about today, is that how to make sure that your software is in the part that will survive, not in the part that won't survive. And this isn't because of everything burning to the ground. This isn't because your data center is going to burn to the ground, or although it might. It isn't because because your HQ is going to be wiped out by a giant storm, although it might. This is because there is stuff coming that is a threat to enterprises that is even quicker. It will happen, that the threat will happen even more in even more guaranteed fashion, even sooner. So the new CBAM legislation from the EU currently only applies, which puts enormous import tariffs, or will eventually put enormous import tariffs on goods and services that are not developed in a low carbon way. Now, at the moment, it only applies to like electricity and cars and things like that. But the EU have already said that within 9 years, they expect it to apply to absolutely everything. It is the GDPR of green, and it is coming. Now, we don't know at what point within those 9 years it's going to apply to the tech industry, but it will happen at some point. And there's quite a lot of work to do. So we really need to get on with it. But it's not only that. There's also, we need to be worried about, thinking about dynamic pricing, which was already a major issue. Well, not a major issue, but a feature of the grids in multiple countries in the EU, and even in North America, some states in North America as well. You will pay more for electricity that is fossil fuel generated, and that's kind of inevitable. We can't all. The world isn't going to go on subsidizing the use of fossil fuels forever. Now, I think that governments are really quite keen not to make consumers pay for this kind of stuff too soon. But I really don't think that they're going to have so much sympathy for enterprises, particularly in the tech sector, where we're intelligent, we're aware, we know what's coming, and we've got money. If we haven't adjusted to renewables and the new features of the grid that come from renewables within a few years, then there really isn't any reason for everybody to keep subsidizing it. So I think that's definitely coming. And of course, customers and people who are working for you, your employees, and it's almost a cliche to say, oh, young people, love young people care about all this stuff. But I don't think it's young people that are actually going to be the biggest people who vote with their feet on this. I think it's going to be people who are more advanced in their careers, because young people don't have that much choice over where they're going to work. If they get a job offer, they're probably going to take it. They're not going to ask around, especially at the moment with making sure that the company is absolutely perfect fit. But as you get older, you care more about this stuff. There was a very interesting report that came from Ernst Young the other day saying that actually boomers are making bigger lifestyle changes, and in fact that boomers the most, and as you go down, young people the least lifestyle changes to accommodate climate change. And I think that people like me, and like I suspect most of the folk in this listening into this to this talk, we kind of care about this, and we feel a bit guilty that we've gone through most of our careers without doing anything about climate change. I do, and now I feel like I should get involved. And so if your company isn't getting involved, then you might lose some of these older folk. But as I say, I'm not a doomer. I think there's loads of things we can do, and there is already some amazingly good news. So when I first started doing this, it's, for example, AWS had no real commitments to hosting in a way that was sustainable in the long term. But in 2020, they came out with a statement, a commitment that they would make the whole of AWS carbon zero by, I think it's currently 2040. Now they were joining there Google, who'd already promised it by 2030. And Azure, who I think are 2030 as well, somewhere between 2030 and 2040. It does change. They do keep moving these dates forward, which is a good thing. But so that's it. That's all the hypercloud providers, all the major public cloud providers, and they're showing leadership there. It's great news. And I when it first came out, when this news first came out in 2020, I thought, because I've been campaigning for it for a few years. I thought, well, that's it. That's great. We're done. As soon as the hyperclouds are green, then we're green. Anybody who's running on the hyperclouds, and I imagine in the long run we all will be, or something that's copying from them in terms of the services that they offer. That will be fine, because we're just running on top of that. The infrastructure is green, then we'll be green. It'll be absolutely fantastic. So that's kind of honeymoon period of me thinking, oh, we've done it. We don't need to do anything else in the tech industry. Lasted about 6 months before AWS let the other shoe drop. They came out with the bad news that went with that good news. And I realized as soon as I saw it, I thought, of course this is the case. And I absolutely should have known that this was coming. So I don't know why I didn't, but I was still surprised when it happened. Which is about the same time that AWS launched their architectural sustainability pillar, or their sustainability architectural pillar, which was also very good news about how you should be architecting to be more climate aware and more energy transition aware in the future. They came out with this graphic, and the graphic was a statement of what they intended to do, which was that, and their position on this, and at least they were clear about it. They said AWS is responsible for the sustainability of the cloud. So that's servers, cooling, water, data centers. They'll provide the services that allow you to be extremely multi-tenant, help you with code efficiency, all those kind of things. They can do all of that. But we as customers are responsible for sustainability in the cloud. And this is actually, if you are just, and this was an absolutely pivotal statement, which actually neither Azure nor Google have made, because it's actually, AWS were very late to this party. They were a long way behind Google, who've been carbon neutral since 2007 for their hosting. But when they did come in, they were much more explicit about what we'd all need to do about it. They communicated better. So I realized that Azure and Google had been making noises along these lines for some time, but they hadn't come out and said it. But AWS really came out and said it. Look, we can build all these services. We can offer you spot instances and multi-tenancy and all the good things that we can do for being green. But you have to use them. If you just move your stuff into the cloud and you don't use the services that we offer, then it won't be getting, we will not bring you with us on the journey towards carbon zero. We will still, you still won't be carbon zero. So this was an absolutely pivotal moment. Unfortunately, there's a hell of a lot of work that we're still going to need to do. So what is green software? What are we talking about here? The Green Software Foundation and the EU are in lockstep on this, in complete agreement on this, which is that there are two areas that the tech industry needs to improve on. Well, not to improve on, to completely, radically transform for the energy transition. One is that we need to really cut the carbon emitted as a result of data center electricity use. So that means we need to cut electricity use, but particularly cut electricity use at times when the electricity on the grid is very fossil fuel intense, is very carbon intense. And we also need to make hardware last longer. And this for this is really overwhelmingly, it's end user hardware. Hardware in data centers is actually managed quite well. But end user hardware, if you start to look at the numbers for the embodied carbon in a device, which is the effective carbon that was released as a result of the work required to build the device, create the device, and dispose of the device. For end user devices like phones and laptops and all that kind of stuff, it massively outstrips the lifetime carbon emissions due to the electricity use required to drive that device. So embodied carbon in end user devices and electricity use in data centers are the two areas that we need to tackle. And that all has to happen on top of variably available power. So what are the key factors that you need to be taking into account when you are making your systems greener or ready for the energy transition? It's your host, your region, your platform, your architecture, your operational efficiency, your ability to demand, shift and shape, your end user device hardware lifespan, and last and actually least, not because it's least important, but because it's actually the last thing you should be addressing, is your code efficiency. And I'll talk a little bit about why that's the last thing you should be addressing later. Now, that's 8 things, which seems like it's complicated, but it's actually not that complicated, because in each of these cases, the things that you need to do are quite sensible. They're aligned with best practice. They're aligned with resilience, cost effectiveness, and security. But you do need to take it step by step. If you tried, some things are much easier to do because there are already tools available to let you work on them. It's already effectively, some of these jobs are already commoditized, and some of them are really not. So you'd be doing loads of custom work to do it. So the key thing is you need to do these in the right order, and that's what I'll be talking about later. So what are we zooming in slightly on this? Your host, you need a hosting provider with a strategy for sustainable hosting. So a committed date for 24/7 carbon-free power and clear progress on that date. So the cloud's now, but so an easy job is just change your host to the cloud and then you're done on that one. But if you're not in the cloud, you're self-hosting, then you need to go and talk to your suppliers and your providers and drive them to come up with some kind of strategy, which is harder for them to do, which I'll talk a little bit about later. But you need it. You've got to have it. It's 101. Whether you buy it off the shelf now, or you drive your suppliers to do it, or you move suppliers until you find one who does. You've also got to choose a region with a green grid. So that makes a huge difference. Some regions are a lot dirtier than others. So AWS now has, I think they have 19 regions that they specifically say they're pretty good on. They've already made good progress on greening the grid. Now, 5 years ago, that was just 5 regions, and most of them were in Western Europe. These days, those regions are spread all over the world. So, yeah, and if you go onto the AWS, so I'm not an AWS shill here. It's just that they happen to be communicating this information quite clearly. So, but if AWS are doing it, the others will be ahead because they're actually better at doing it. They just don't talk about it so much. But it does mean that there are regions all over the world for you to do this. Have a talk to your supplier about where you should be hosting, which region you should be hosting it. Now, this is where the next thing we need to be thinking about is operational efficiency and machine utilization. And this is where the cloud has a tendency to win, because it's entirely, the whole premise of the cloud is that they can cut their costs by using better machine utilization based on multi-tenancy. And older data centers don't tend to have that kind of multi-tenancy approach, and they don't use software managed multi-tenancy in the same way the clouds do, but they need to. If you look at that, the work the EU is doing through the SDIA initiative, their SDIA initiative, that's all about trying to push all data centers to adopt this multi-tenancy approach. They're using Kubernetes to do that. So again, it's not unreasonable for you to talk to your suppliers and say, what is your multi-tenancy strategy? Because without that, you do not get the high density of workloads packed onto your machines that give you really good efficiency of hardware, which is good for your embodied carbon emissions, and also electricity use. Because a machine that's turned on uses pretty much the same electricity, whether it's fully utilized or partially utilized. So we need all the machines to be very fully utilized. And multi-tenancy is an advanced thing here, but there are things you can do that are quite basic to get your machine utilization off. So it's turning off defunct or zombie workloads. Who did this? It was VMware cut their hosting bills and machines and therefore electricity use and embodied carbon bill by 66% recently when they moved data centers in Singapore, and they realized that 66% of the servers were doing things they didn't really need them to do anymore. So there's loads of good work that can be done just with very basic manual, and then you can worry about automating it later. Auto scaling, right size the machines you've got, machine utilization is incredibly important. Then we're into architecture. Now, this is really all comes down to demand shifting and shaping. So I mentioned earlier that renewable energy is not available all the time. Sometimes it's night and the wind isn't blowing. So we need to be able to move our tasks around in time. I mean, you can do the whole follow the sun thing, but it's easier if you can just find tasks that are delayable, and you can delay them until the sun is shining. So that works better if you've got a single on-demand monolith, then that's quite hard to do. But if you start to, you don't have to go crazy, but if you start to distribute your systems a little bit, start to pull off tasks that don't need to run on demand, that do have a little bit of wiggle room, even a small amount of wiggle room helps here. So that you can run them a little bit later when the electricity gets cheaper and greener. Now, I don't think that you should be writing all this to do it yourself. I think you should be using services to do it. So spot instances are a really good example, and you can run spot instances on-prem with Kubernetes, as well as spot instances or preemptible instances are available with all the clouds. Now, they're not at the moment. All the clouds are using spot instances to get your machine utilization up, which, as I say, has benefits. But in the long run, we'll be able to use those kind of instances which say, look, I don't mind if this runs a little bit later, to shift stuff in time so that it can run when the sun is shining. There are other kinds of flexibility, things like burstable instance types and stuff like that, which again, all very, very good for machine utilization, very good potentially for demand shifting and shaping in the future. But yes, distributed systems, start thinking about what's urgent and what's important, because they're not necessarily the same. And as I said, last and actually least at this stage is code efficiency. And it pains me to say this because code efficiency was my life for quite a while. But writing code in C or Rust or any of these, or even worse, assembly language, is slow. It's bad for developer productivity. So you don't want to be doing it unless you really, really have to do it, because you're writing high performance code. Generally speaking, we need to be looking at managed services, serverless, green platforms that will do a lot of this stuff for us. Now, you might have read about the whole incident this year where there was a giant hoo-ha about AWS moving the video. AWS video service was Prime Video Service. It was discovered that they had just rewritten it to, they had been running on serverless, but they'd rewritten it all to be very, very tightly written, a distributed system and kind of combination of monoliths and distributed stuff. And everybody went, oh my God, that means that serverless was always terrible. We should never have used serverless. No, it was an excellent example of the fact that doing these things is really hard. Getting a really hyper optimized system, like I assume they have now, or probably you can always optimize more, but more optimized than they had previously on serverless. It wasn't worth it for them until now. Even though they had enormous amounts of use, it still wasn't worth it for them until now. So I think we learned the lesson there. They went to serverless first. And then later, when they realized they had massive scale and they could afford to put in all the effort, they moved to actually just doing it themselves in a fully custom solution. Look at, unless you are running Amazon Prime, you should be looking now at green platforms, things like greener serverless WASM, that kind of thing, that will allow you to get code efficiency without necessarily you having to rewrite everything in C. Eventually, you'll know whether or not you ever have to do that, but most people will never ever have to do that. Now, one of the interesting things here is is the order matters. There are lots of different things that you can do here. As I said, there are 8 different things that you need to look at, all of which require a lot of work, but they're all quite sensible work. There's nothing crazy about it. It's all kind of aligned with best practice generally. But it's incredibly important that you do it in the right order, and you only do the bits that are relevant and material to your business. If you are writing the next Amazon Prime and you've already established that you really, really need it to be incredibly high scale because you've already got 1 billion customers, then go crazy and optimize everything, rewrite everything in C or assembly, and put in your massively complicated distributed system. But for most of us, if we try to do that, we will go out of business. So we need to, and that kind of stuff isn't available yet, but there's loads of green stuff that is available off the shelf now. And this is why at the Green Software Foundation, we introduced the Green Software Maturity Matrix. Now, this was a spin-off. This officially launches in January, and it is a public project. So anyone, you don't have to be a member of the GSF to contribute and to get involved with this. As I say, it launches in mid-January, and I'm going to be the project lead. And I can assure you that we want all the people to be involved. We want to hear loads of, we've already had loads of feedback, and I've already got loads of feedback from people outside the GSF. Because we originally wrote this for the O'Reilly book, Building Green Software, and then realized that there was such interest in it, and it was so useful as a way of working out, of structuring and ordering the tasks that we were describing in the book, that we decided to actually get the Green Software Foundation on board, and very keen to do so. So the green software matrix is a classic maturity matrix. There are 5 levels of maturity for this, going from aspire, level 1, aspiring, level 1, to aware, to acting, to awesome, to inspiring. And the reason we did it, and it breaks down into basically this kind of 8, I think we've actually got 9 areas here because we've put in training as well, because you do actually need to know how to do this stuff. It's the idea of this is to kind of reassure everybody as to where you are now, where even the top people are now, and how much work there is to do, and how you just have to do it gradually and in the right order. Because, as I say, some of this stuff is already commodity, and some of this stuff is massively custom. So you want to be doing taking advantage of the commodity stuff whilst you're waiting for the custom stuff to also become a commodity, because it will. I mean, there's amazing stuff going on in there. So I've got a little bit of a zoom in here. Here we go. Right, about what's actually involved in each of these levels. So to reassure you, almost everyone is currently at level 1, aspiring. That means that there are individuals within a business who are interested in going green, but organizationally, you're not really in the game. It's not something that your CEO is talking about at every board meeting, whatever. And as I say, that is where almost everybody is, and it'll be where all of you are, almost certainly, because you're here. Therefore, you are at least at level 1. You're not level 0. There's somebody who has some interest in this, but you haven't really started yet. Level 2 is you're starting to get some data. So level 2, you've got your scope 1 and 2 emissions data across your organization, and you're starting to take some action to reduce your emissions. So in the book, we set a level 1 to level 2 in the O'Reilly book, Building Green Software, which I'll push again. We set a challenge at the end of the book to get from level 1 to level 2. And we think that a good indication that you are on that journey, it's at least started to be in level 2, is for you to cut your hosting bill in half. It might seem like that's a crazy idea, but at this stage, at level 1, level 2, hosting bill is a really good proxy for your carbon emissions. There are lots of ways to cut your hosting bill in half, many of which we suggest in the book. I spoke to quite a lot of consultancies about how much they'd been able to cut people's hosting bills with a bit of focus on it, and they were saying 30 to 50% is the standard. And that's, so that is the standard. You look at what VMware did, cutting 66% of their bill just by closing down their zombie services. Cutting your hosting bill in half, and therefore basically cutting your carbon bill in half, is very doable. It's quite an attractive little project, and it gets you in the game. It's a good place to start. So for 1 to 2, cut your hosting bill in half. And at the same time, you need to go off and talk to to find out what all your scope 1 and scope 2 emissions are. Now, it's worth pointing out that 5 years ago, if you knew your scope 1 and scope 2 emissions, you could just buy offsets for them, and you could call yourself carbon neutral. And that was really considered to be great. So number 2 was carbon neutral, and that was great. But the world has moved on. That's now only level 2 on a 5-step matrix. So if you're not there, you're a long way, but most of us aren't. You're a long way behind where we need to be. But we have got hopefully 9 years to do it, maybe less, depending on what the EU decide they're going to do with this CBAM legislation. Once you've kind of started to do all and at this stage, at the low levels of the maturity matrix, you've actually got loads of opportunity. There's loads of stuff you can do. You have the superpower of currently being a bit rubbish. There's loads of improvements that you can make here to cut your hosting bills and therefore cut your carbon emissions. And they're all around kind of like decent, good ops and using services that are available to you, and there's and going as multi-tenant as possible. There's really this, you don't have to do loads of measurement, you don't have to start tuning your applications, you don't have anything else to get to, you don't even really have to start doing that until you get to level 4. At level 3, you need to go out and find out what your scope 3 emissions are as well. You need to know all of your emissions, and you need to be automating some of that operational stuff that you did at level 1 and level 2 to cut your hosting bill. So and you need to have good static knowledge of what your footprint is, so that every 6 months or so you can be looking at it and going, is this going down? Am I per unit of per user or whatever? It doesn't have to necessarily be going down overall, but like for like, it needs to be going down. And then at level 4, that's when we start to get into needing to have really good real-time dynamic knowledge about your systems. And this is where I wouldn't say even start thinking about code efficiency until you get to level 4. You do operational efficiency for 1, 2, and 3, code efficiency at level 4. And only at level 4 do you need a really good metrics and measurement ability. Up until then, at level 1, 2, and 3, you can do it based on stuff that you just know is going to work. So cutting your hosting bill is just going to work. Moving to green regions is going to work. Moving to hosts that have a good commitment to being green will work. Adopting platforms that have the ability to demand, shift, and shape will work. You don't need to measure for those things. You know that they're gonna start working. So at this stage, 1, 2, 3 is all about adopting the commodity good best practice operational stuff that is already out there. So you don't need to worry about that. Now, you don't need to worry about measurements at this stage. At level 4, you do need to start worrying about measurements, and at this point you will be looking to, and you will need good real-time dynamic knowledge of the carbon emissions from your system. But who is at level 4? At the moment, we reckon that Azure is at level 4, Google is at level 4, and AWS is at level 4. I'm reasonably we can be fairly confident that that's where they are. They're not at level 5 yet. They're at level 4, and it's a reminder to all of us to not go crazy. You don't have to jump straight to level 4. In fact, do not jump straight to level 4. Go through level 1, 2, and 3 first. Operations first, then worry about tuning. And at that point, maybe you will be starting to rewrite replications in C. You'll have identified all the stuff that's shiftable, and you'll be shifting it. So you won't necessarily have to optimize those bits of code anyway. They'll be in spot instances or something equivalent. So you don't need to worry about optimizing those bits of code. The bits that have to run on demand, you are going to have to need to start optimizing those. But ideally at that point, you will not be writing code or rewriting your code to be optimal then. You'll be porting to platforms that will provide that code efficiency for you. I mentioned there's one of the excellent examples of this, and this comes up all the time, is people look at charts that I'm sure you'll have seen that show that C is 100 times more efficient than Python, which it is. There's no doubt. For certain tasks, C is definitely 100 times more efficient than Python. But it's very developer unproductive to write in C compared to Python. But if you look at the Python community, they are now quite aware of this. There's a project called Cython, which is about cross-compiling Python to C to execute, so that you can keep some developer productivity. You're not compiling all the way down to assembly language. You can at least read your code that you've written, but you get the performance improvement without having to rewrite your own code in C. So there's Cython. There's a tool called Mojo which has a similar premise, but it's not Python, but it has similarly very easy to use language, and it compiles so it runs very quickly. Serverless WASM WebAssembly is also working on this. Now, they have interestingly focused entirely on operational efficiency first, because it's serverless, and they're looking at extreme multi-tenancy. And totally agree with their decision there. But they've also started to talk about now that once they've got the operational efficiency nailed, they're going to look at code efficiency. So I'm not saying that those are the platforms you have to use. What I'm saying is green platforms are under development. They will take some time to get to the point where they're really humming and easy to use and integrated with clouds and all that kind of stuff. But they are coming. So you don't need to run to do it yourself. Sort out your operational side, and then by the time you get to level 4, hopefully there will be tools that will enable you to get to level 4, and also from level 4 to level 5, where nobody is at the moment. Because where we need to be is 24/7 CFE, 24/7 carbon-free electricity, with maybe 1% offsets. You're really talking about having a tiny number of offsets at that point. So I've moved through that at an incredible rate. I hope that wasn't too fast. So the reason why me and my co-authors, Sarah Sue and Sarah Bergman, wrote Building Green Software is because there's a lot of stuff to grok. And it's not detailed stuff. Building green software is not about the details. It's about the high level. At a high level, this is where we're going. These are all the things that need to change. We cover code efficiency, operational efficiency, carbon awareness, which is demand shifting and shaping, networking, measurement, monitoring, and the maturity matrix. So all of this stuff is in there, and the book is coming out in April. And when it comes out in April, it will not only come out as an O'Reilly book, it will be simultaneously released by O'Reilly under a Creative Commons license. So even for folk who can't afford an O'Reilly subscription can still have a read through of it. Now, it's already half of the book, and in fact, most of the stuff that I've just talked about here is already available on the O'Reilly website. Now it's an early release, so it's very rough and ready. It was very much a first draft, but you can read through it and get the gist of what I've said in a slightly less rushed form. And we're very happy for you to give us feedback on, well, I was about to say, up until now, I've tended to say, it's happy for you to suggest things that we should add to it, but we've now actually locked we're just in the editing phase now, so that in readiness for the launch in April. And hopefully at some point we'll find out what the animal's going to be, because it's not going to be that little cute chick, because that's just for early release stuff. So go and have a read of it. It'll be fantastic. But if you want any training on this, so this is finally my pitch for self. I have set up a company that, if you look on my LinkedIn profile, to start doing training around this. So online training around building green software and consultancy. So if you're interested in that, come just give me a call on LinkedIn. So that's it. I think we're ready for questions, and hopefully we'll have quite a lot, because this is an area where we need to be asking a lot of questions and really challenging our assumptions and what we read about what matters and what doesn't matter, because so much of what's said online about this is focusing on the wrong things. We do need to be making decisions that are going to scale. Not, it's not all about deleting your own personal emails so that they're not saved or whatever. This is about scalable platform choices and putting pressure on suppliers. This is not about your individual efforts. This is entirely about your system. So thank you very much.
Thank you, and that was really a brilliant talk and extremely interesting. Green software. So I got one question here in the chat, and two, I think. Yeah. The first is, what do you mean by carbon free? Does buying carbon credits count? And if yes, how to transition to real reduction?
It doesn't. Carbon-free means really no carbon. It's the whole of the idea of green software, and the Green Software Foundation's statement is really you can't buy carbon credits. You have to cut the amount of carbon that you're actually putting into the atmosphere. That is the only option here. Now, as I said, 5 years ago, carbon neutral of your scope 1 and scope 2, and you just offset it all with carbon credits, whatever, seemed like it was good, but we've just gone beyond that now. We need to just not be putting carbon into the atmosphere anymore. That's where we have to be. None of the offsets are all that good. It's even planting trees, it's just not that good. It does not offset carbon that goes into the atmosphere. So the goal here is no carbon. And I know that sounds impossible, but it's really not as impossible as you might think. And it's, obviously there's still embodied carbon in solar panels and wind turbines and things like that, but it's very small compared to a coal-fired power station or a gas-fired power station. So we focus ourselves on using green energy, and also making devices last a lot longer, making end-use devices. So never let your code be the final nail in the coffin of working hardware, because if I have to, and I know I will have to, I'm going to have to throw away this bloody phone again because it's going to be out of security patches. It is a perfectly working phone. It's my dream that it would end its life by me accidentally dropping it down the toilets. But no, it will always end its life because I run out of security patches.
Thank you for answering this question. The next question is, in your experience, how do we get decision makers, company leaders, public leaders, customers, business partners to agree to invest in sustainability?
The best argument at the moment is to point them, I think, at the EU's CBAM legislation, because I think it probably isn't as hard these days as you think it is, because everybody's starting to wake up to the fact that legislation is coming. So yeah, at the moment, if you look at the CBAM legislation, you go, oh, la, 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 it only applies to electricity producers. But if you look at the details, they're saying this is going to apply to all goods and services within 9 years. And 9 years is probably about how long it'll take us to get from level 1 of the maturity matrix to level 5 of the maturity matrix. So that means you have to get started. But as I said, get started by cutting a hosting bill is my advice, because at least then you kind of got a double win there. You can measure your progress, because you can just say, well, the hosting bill is half, the carbon bill is broadly half, and if you and also saves you money. So it's an easier win. I would start there. I mean, you're just going to have to bring all the guns to bear on this and just say, look, it's ethically required, it's socially required, it's legally required. All our employees want to do it. We know it's coming. If we don't put pressure on our suppliers, we don't find suppliers that have good commitments here, it's entirely possible the supplier will just disappear. So it's just resilience for your company these days, all the things.
Okay, I think this was the last question, and then thanks a lot for being with us, and thanks to everyone for attending this session.